George Boole, the architect of Boolean algebra and the logic of thought. George Boole, a mathematical pioneer renowned for his groundbreaking work in Boolean algebra, has left an enduring legacy that resonates in the realm of digital computer circuits. His journey as a self-taught mathematician began at the age of 16 when he embarked on a teaching career that ultimately led him to become a mathematics professor at Queen's College, Cork. Born on November 2, 1815, in Lincoln, England, Boole's profound contributions to the understanding of logic laid the foundation for the evolution of computer science and modern digital electronics. Boole's early life was marked by financial challenges, yet his insatiable thirst for knowledge propelled him to teach himself, especially in the realm of mathematics. Raised in a modest household, his father, a tradesman with limited formal education, recognized George's intellectual prowess early on. Boole's voracious appetite for learning saw him immerse himself in the works of the great mathematicians of his time, setting the stage for his future groundbreaking contributions. In 1834, at the tender age of 19, Boole took a significant step by opening his own school in Lincoln. This venture not only showcased his commitment to education, but also reflected his unwavering belief in the transformative power of knowledge. Despite facing financial hardships, Boole continued to refine his mathematical skills, drawing the attention of influential mathematicians. In 1844, this recognition culminated in his appointment as the first professor of mathematics at Queen's College in Cork, Ireland. Boole's most notable impact lies in the realm of mathematical logic, where his work in differential equations and algebraic logic marked a turning point. At a time when the prevailing approach to logic was predominantly verbal and lacked precision, Boole's seminal work, The Mathematical Analysis of Logic, 1847, ushered in a new era of logical reasoning. Introducing algebraic methods to logic, Boole provided a mathematical framework for reasoning about propositions and their relationships. The crux of Boole's innovation lay in representing logical propositions and operations through algebraic symbols and equations. Variables, constants, and logical operators such as and, organ, and not became the building blocks of a symbolic logic system, later coined as Boolean algebra. This system allowed for the manipulation and analysis of logical statements using mathematical techniques, providing a systematic and rigorous framework for logical reasoning. One of Boole's enduring contributions was his theorem asserting that any logical proposition could be expressed using a combination of and, organ, and not operations. This theorem laid the groundwork for the development of electronic circuitry and computer programming, becoming a foundational result with far-reaching implications. Despite initial lack of recognition, Boole's work gradually gained acclaim as scholars and scientists acknowledged its profound implications. His ideas found resonance in the works of subsequent logicians and mathematicians, including Augustus de Morgan, Charles Sanders Peirce, and Ernst Schroeder. Boole's influence extended beyond mathematics, leaving an indelible mark on philosophy and computer science. Boole's logical methods were not confined to theoretical realms. He applied them to practical problems. His work, An Investigation of the Laws of Thought, 1854, delved into the application of his algebraic logic to the analysis of reasoning and the human mind. Boole posited that logical reasoning, expressed through his algebra, could model and understand the processes of human thought, foreshadowing developments in cognitive science and artificial intelligence. Tragically, George Boole's life was cut short at the age of 49 when he succumbed to pneumonia in 1864. Despite his relatively brief life, his impact on the field of mathematics endured and continued to grow. The significance of Boolean algebra became increasingly evident with the rise of electronic computing in the 20th century. In the mid-20th century, Claude Shannon, an American engineer and mathematician, recognized the applicability of Boolean algebra to the design of electronic circuits. Shannon's influential work on digital circuit design, published in his master's thesis at MIT in 1937, showcased how Boole's algebra could represent and manipulate binary relationships in electrical circuits. This laid the foundation for the development of modern digital computers. Boole's legacy extended to the programming world, where Boolean logic became fundamental in programming languages, shaping decision-making and control flow in computer programs. The binary system, based on Boolean algebra, became the language of computers, with the digits 0 and 1 representing the logical values of false and true. In recognition of his contributions, George Boole was posthumously honored by the scientific community. His algebra, initially formulated to address questions of logic, evolved into a powerful tool with broad applications in computer science, electrical engineering, and information technology. Boole's impact transcends academia and technology, permeating everyday life. From the design of computer circuits to the development of algorithms and programming languages, Boolean logic is ubiquitous in the modern world. Boole's ability to bridge abstract mathematical concepts with practical applications exemplifies the transformative potential of mathematical thinking. Beyond his intellectual contributions, Boole's life story serves as an inspiration. Born into humble circumstances, he overcame financial constraints and a lack of formal education to become a pioneering mathematician. His dedication to education, evident in his establishment of a school in Lincoln and later professorship, underscores the belief that knowledge is a powerful force for positive change. In conclusion, George Boole's legacy as the architect of Boolean algebra and the logic of thought is a testament to the enduring power of mathematical ideas. His work laid the groundwork for the digital age, influencing fields as diverse as computer science, philosophy, and cognitive science. As we navigate the complexities of the 21st century, Boole's contributions continue to shape the way we think about and interact with the world, demonstrating the timeless relevance of mathematical reasoning.